Let's have a look at the answer to question 1A, part 2. So, meals are cold if they arrive more than 20 minutes after leaving the kitchen. So that more than 20 minutes is important. And we're asked to find the probability that they have a cold lunch and a cold dinner. So I need to look at both my lunch and my dinner distributions. So what I'm just going to do is I'm going to put this information on the graph here. And so I have my lunch has a start of 5 and goes up to 25, and my dinner starts at 5 and goes up to 30. And we did find the heights of those. So our heights for our lunch was 0.05 and our heights for our dinner was 0.04. Okay, so we were told they're cold if they're more than 20 minutes after. So I'm going to draw myself a line at 20 minutes, and more than 20 minutes I want to shade that. And equally for dinner, draw a line for 20 minutes and I want to shade in more than 20 minutes. So we need to find these probabilities. And once I find those, I'm going to come back to this probability of and, where and, remember, means times for probability. So let's find these probabilities first. So for lunch, I know that the probability is equal to the area, and the area of a rectangle is base times the height. So in this case, my base, so that's the distance there, my base is 5, and my height is this distance here, which is 0.05. So that gives me a probability of 0.25. Now I'm going to do the same for my dinner. So in this case, my base here is 10, my height here is 0.04. So to find that probability, that is the base times the height, and that will give me a probability of 0.4. So that's found the probability of being late at lunchtime and the probability of being late at dinner. And now I need to combine those to find the probability they have a cold lunch and a cold dinner. So that is my last step. So I want the probability of a cold lunch and cold dinner. So that means I want to do the probability of the lunch times the probability of dinner. So that's going to be 0.25 times 0.4, and that will give me a value of 0.1. So there is our probability.